Every department on campus is using a cluster to do some type of research. A cluster like this is what is required today to do modern science.
The University of Alabama at Birmingham is a comprehensive research university. This is a young, nimble research university, highly ranked. We bring in close to $500 million in NIH funding for research every year. Our intent is to change the world, and nothing less than that. So we are very intent on genomics research, cryptography research, brain mapping, personalized medicine.
Personalized medicine is creating individualized therapies to treat not only the disease, but to treat the disease that any particular patient has. When you look at the data that we work with, especially human genomic sequence data, it's impossible to analyze that using the past resources that we have.
The data that I work with is very large. We're talking gigabytes to terabytes in size. And a normal desktop computer would take months, even years, to analyze just one project.
The computer resources that we have available now through our high-performance computing system named Chiaha, those are able to now analyze those data in a matter of hours, where it would have taken days or weeks before.
The cluster is essential not only for the speed of the analysis, but also to be able to support everyone here at UAB, from the clinicians on the medical side to the researchers here on the research side.
I study how it is that the brain is changed by experience. To be able to help people who have loss of central vision, we use functional MRI to look at the level of brain activity over time. And we can look at it in every part of the brain simultaneously. So we get an enormous amount of data out of this method. It would take about 24 hours to do a simple processing stream on one brain. And now, with the new cluster, with Chiha, we can do 100 brains in less than the same amount of time. It's absolutely critical that we have a cluster like Chiha to be able to do this kind of work, because that just makes everything that we do possible that wasn't possible before.
In looking at high-performance computing and looking at empowering greatness in others, we chose Dell, EMC, and Intel to work with us to deploy this system, and it's been a great partnership.
The current configuration of Chiha has about 2,300 cores, and the cluster consists of two types of Dell EMC servers, the Dell EMC R630 and the DSS 1500 servers. And each of the servers has the Intel E5 2680 processors. This new cluster essentially increases our computational capability by 10 to 11 folds. We had a 10 teraflop computer earlier, now we have a 110 teraflops computer. We also have a couple of nodes with the newer generation Intel Xeon 5 accelerator cards. This allows us to get our users ready when we have the next generation of the Intel mini-core processors readily available. We can easily get them order of magnitude increase in their performance by taking advantage of this architecture.
The research computing infrastructure at UAB is spectacular, but the physical infrastructure is not going to work unless you have the really great personnel to help people do what can be done with that wonderful piece of equipment.
Designing a cluster to meet a large number of user requirements is always a challenge. It's a major collaborative effort between Dell EMC and Intel. They have been phenomenal in setting up the cluster from rack and stack to cabling it to configuring it. We also put in training.
We're trying to remove those barriers and automate processes to take tasks off of faculty members so they can focus on solving these very difficult challenges. We're looking at the most difficult problems facing mankind, and we're trying to solve those problems for the benefit of the entire planet.